FM. FM broadcasting is radio broadcasting which uses frequency modulation, that is FM technology. It was invented in 1932 by American engineer Edwin Armstrong. FM is capable of better sound quality than AM broadcasting, as it uses VHF, that is very high frequency. Frequency modulation conveys information by varying the frequency of a carrier wave, while amplitude modulation varies the amplitude of carrier, keeping its frequency constant. FM band covers around 88 to 108 MHz. Let us understand FM radio receiver by block diagram. This is the block diagram of FM radio receiver. It starts from aerial, which is an antenna. It receives many signals, out of which not all are the desired one. So we need to select the desired signals. So the signal received by aerial enters the RF amplifier. RF amplifier selects and amplifies the desired station from the many. The selection frequency is not fixed. It can be altered. This is called tuning. In cheaper receivers, the tuning is fixed and tuning filter is wide enough to pass all signal in the FM band. Now, the tuned and amplified signal is entered into the mixer, into one part of the mixer. This is the local oscillator which enters the mixer from the other port. Local oscillator and mixer form a frequency changer circuit. Local oscillator may consist of variable frequency. It can be tuned by altering the setting of a variable capacitor. It provides sum and difference from frequencies of oscillator and input signal. Now, once the signals leave the mixer, they enter the IF stages. IF stage. These stages contain most of the amplification in the receiver as well as filtering. It enables the signal on one frequency to be separated from those on the next. It is a fixed frequency amplifier which rejects the unwanted signal, and it is a fixed frequency of 10.7 MHz. Now, once the signal have passed the IF stages of receiver, they need to be demodulated. FM demodulator. This circuit recovers the audio signal and discards the RF carrier. Different demodulators are required for different types of transmission, and hence some receiver may have a variety of demodulators like AM diode detector, synchronous AM, etc. Here we can see some of the signal is fed to oscillator. This is AFC, that is automatic frequency control. Now this is the sum of audio which is fed back to the oscillator as AFC. This ensures that oscillator frequency is stable in spite of temperature changes. The output from the demodulator is recovered audio. This is passed to audio stages, that is AF voltage amplifier and AF power amplifier. In this, they are amplified and presented to the headphones of speaker. In power amplifier, the power level is increased sufficiently to drive the loudspeaker by the power amplifier. Let us understand the FM radio receiver circuit. This is the FM radio receiver circuit. There are three main circuits in this. Circuit number 1, circuit number 2, and this is the circuit 3. Let us take these circuits one by one. First circuit. In this we have capacitor, inductor and the antenna from where signal is received. The signal is caught by adjusting the capacitance of variable capacitor. This is the variable capacitor, so that the resonant frequency of LC circuit equals the frequency of signal to be received. The second circuit is it comprises of resistance. One is the fixed one and other is variable, and capacitor plus transistor. C2 is a coupling capacitor. It removes the carrier frequency from amplified signal, that is demodulation. Variable resistance is used to control the volume of audio. Transistor Q2 and the Q1 in the previous diagram, this Q1, are used for detecting the frequency modulated signals. The last circuit, it consists of op-amp, which is non-inverting, and two capacitors plus headphones to output. The operational non-inverting amplifier increases the amplitude of input signal. C3 bypass capacitor, it removes the noise from the output signal. C4 is a coupling capacitor and it removes the DC component. And finally our signal reaches headphones. This is the output what we get. There is one question on FM radio receiver. Suppose a user wants to select 93.5 FM radio frequency, and which component of the radio receiver will help him to select the station? As we have already seen in this circuit diagram, this C1 and this L, we need to set these C1 and L so that, as we already have read, that we need to equal the resonant frequency to the frequency of signal to be received. So we need to set value of C1 so that resonant frequency F0 become 93.5 FM in this case. So the value of C1 is calculated from the formula, that is F0 equals to 1 by 2 pi root over LC, where L is the inductance which was shown in the previous circuit, and C is the variable capacitance. So here L is already fixed and we need to change the or to set the values of C to set our frequency